Hi, Assalamualaikum to Dr. Nurul Huda binti Ahmad Ishaq. I am Nur Fasihah binti Muhammad Fauzi S58411. Today, I would like to present to you about the ocean ion fertilization. From this presentation, we will figure out about history of ion hypothesis, area of ion fertilization, importance of ocean ion fertilization, OIC experiment, is this experiment is success or not, and the future OIF experiment. The ocean ion fertilization is defined as ocean biological pump that draws down atmospheric carbon dioxide by adding nutrients to boost phytoplankton growth and as a result, carbon export to the deep ocean or sediment. Martin hypothesis states that ocean ion fertilization can stimulate oceanic carbon sequestration through biological pump in iron-limited, high nutrient and low chlorophyll region. Addition of iron will significantly boost the primary production. As a result of lack of iron, he believed that area of the ocean with the high nutrient, low chlorophyll will have low phytoplankton growth. Next is about history of atmospheric gas composition in ancient times. This was analyzed by trapped air bubbles in Arctic and Antarctic ice cores. It shows that atmospheric carbon dioxide was around 180 ppm during last glacial maximum, which was 20,000 years ago, was much lower than the pre-industrial times, which are around 280 ppm. The main objective of this OIF experiment is to promote phytoplankton growth to remove carbon from the atmosphere and into the ocean. Area of ocean ion fertilization was divided into two categories, which are high nutrient low chlorophyll and low nutrient low chlorophyll. For high nutrient low chlorophyll, 2 experiments in equatorial Pacific, 3 experiments in subarctic North Pacific, and 7 experiments is conducted in Southern Ocean. It is unable to fully utilize macronutrients for photosynthesis. As a result, higher availability of macronutrient primary production in this higher nutrient low chlorophyll relatively low. Whereas in low nutrient low chlorophyll, one experiment is conducted in subtropical North Atlantic. It is predominantly occupied by nitrogen physics and generally co-limited by phosphate and iron. The next slide is about relationship between the iron and carbon. As a higher concentration of iron fertilization will decrease the carbon concentration in atmosphere. When plankton are photosynthesizing, they will absorb carbon from the water surface, resulting in a bloom that is eaten by other creatures. Result from biological pumps, carbon from plankton will combine with waste product and other particles to become marine snow. As iron added to the ocean surface stimulate phytoplankton growth, the iron in the ocean will increase the amount of carbon that is transported from the surface water to the deep ocean. Once the carbon reaches to the deep ocean, it will sequester or seclude in the deep water for centuries. Limitation of each experiment are iron EX1, iron EX2, sulfates N, soyri, Ancient X, sulfates S, sage and 61. For iron EX1, the limitation are subduction of fertilizer patch, single ion addition, and micronutrient or macronutrient limitation. Iron EX2, no export flux measurement in the deep ocean, and insufficient experimental duration. Sulfates N, entrainment of dissolved silicate into the fertilizer patch by physitonizing, and there is no direct measurement of export flux with the sediment trap. Sorry, there is insufficient experimental duration. Instant X, like limitation by storm, insufficient experimental duration. Sulfates S, insufficient experimental duration. And net SAGE, high dilution rate by small batch size. And lastly, 6.1 experiment. Limitations are single ion addition and insufficient experimental duration. All these experiments are considered as success. A few experiments were considered as successful, such as effects, the Hanfacts series 62 and fit, because there is no limitation in this finding, whereas some experiments have limitation on their finding experiment. The experiment of ocean ion fertilization has resulted in a shift in the phytoplankton community size from picophytoplankton and nanophytoplankton to microphytoplankton, grazing rate of mesozooplankton and initial concentration of silicate seems to limit the development of the atom-dominated blooms. For example, Phipps' experiment has increased in picophytoplankton abundance, potential future for ocean ion fertilization. This experiment can be improved to achieve their main goal, which few factors such as location, duration, strategy, effective tracing of fertilizer patch, and the effect on marine ecosystem. First, location. Experiment should be conducted in the center of the eddy structure when grazing pressure is low and silicate level are higher during summer. Duration, shipboard observation must be made during a minimum of 40 days with multiple ion injection. Long-term observation will produce longest ion-induced bloom. Strategy, the ion fertilization patch must be traced using both physical and biogeochemical tracer. Effective tracing of the fertilizer patch, the NBST system, which is stand for neutrally beyond sediment traps and water column derived 234 thorium method are employed at 2 depth to estimate the accurately carbon export flux. And lastly, effect on marine ecosystem. Use optical sensor equipped autonomous MOR profilers or autonomous BINTI vehicle to determine the decline of oxygen content and production of climate relevant gas and toxic decay. There is my reference of this presentation. That's all from me. Thank you.